Now let's start with fitting our polynomial regression model. For that, we need to transform our features to polynomial features. So let's call a sklearn library that will do that work for us. Preprocessing, import polynomial. This will help us, this module or this library will help us particularly to transform our features, that is the temperature feature, to our polynomial feature. So let's fit it out. Poly is equal to, let's initialize it, polynomial features, and let's keep the degree is 4. By default it's 2, but let's keep 4, and let's transform our features. So x poly will be poly dot fit transform, because we are transforming our features, first fitting it, then it is transforming it. So let's take what we have in x. Okay, so let's convert that. If you want to check x poly, so we have x poly as this features. You can see that all of these are of square of that issue. Yeah, so this looks just fine. Now we will train our model using this x poly and y. So poly dot fit, so polynomial degree features degree equals to 4, and now let's train our linear regression model. Let's again call it, and now let's fit our model. We have x poly and we have y. So successfully our linear regression model has been fitted out with x poly and y. Now let's try to predict everything. So par underscore y, that is polynomial regression of y pred. So lin2 dot predict, and here inside of this we are going to fit transform of x. Okay, these are the values and the real values are of y. Now we are going to plot a graph, sort of the same graph that we have over here. Now rather than writing sry, we are just going to change it to pry, and let's name this as polynomial regression. Now you can see that right now the regression model that we are having is far better than what we were having before. If you want to predict any value, so before we were predicting out for 60 where we were getting 0.089, let's predict it out. Okay, so 0.027. So for 60 it's 0.027. So that's exactly what we were looking for. So that's the vast amount of difference that we can get from polynomial regression and linear regression. So if I check side by side, the same value with linear regression, simple linear regression, we are getting 0.08. With polynomial regression we are getting 0.027. That's the amount of difference we can get. Let's plot the same thing in the same slot. So plotting that, I'll just copy this, paste it out over here and change it to SR. Let's change the color to green. Okay, so that's the difference between both of them. So for polynomial regression we have this curve, and for linear regression we have. Now before ending this session, let's have a side-by-side comparison of our real value, that is our expected values, with the linear regression values and with the polynomial regression. What this particular line of code will do is it will just give me the real y value. We will be having the linear regression values, that is the SRY, and the polynomial regression value, that is the PRY. So we are just passing out the complete dictionary and creating a data frame out of it. Let's look into this. Now you can see the vast amount of difference in this. So y is 0.002 over, for linear regression it's a negative, for polynomial regression it's quite the same thing. Not exactly the same, but quite the same thing. So that's where we will be using polynomial regression. That's it for this video. In our next lecture, we are going to start with decision tree regression.